Welcome to this explainer. Okay, if you've been tracking the whole agentic AI explosion lately, you've definitely seen the headlines. You know the ones. They're constantly pitting Google against Anthropic in this massive winner-take-all protocol war. But we're diving straight into the technical source material today, and guess what? That whole idea, it's literally a complete misconception.
So let's just go ahead and address the elephant in the room right off the bat. The internet absolutely loves a good fight, framing this as an epic battle, A2A versus MCP. Who wins? You see these endless debates online, right? People are agonizing over whether to choose Anthropic's Model Context Protocol, MCP, or Google's Agent-to-Agent Protocol, A2A. It's like developers are treating them as these totally mutually exclusive paths for their enterprise architecture. But is that actually the case?
Here is the massive paradigm shift you need. When you actually get under the hood and look at the architecture, they are not competitors at all. Actually, scratch that whole rivalry idea, because they form a cooperative stack. The real question isn't A2A versus MCP. It's how do these two work together, because they solve fundamentally different problems at completely different layers of your AI infrastructure.
So here's our roadmap for today. We'll start with the connectivity problem, then break down MCP as the tool layer and A2A as the communication layer. After that, we'll look at the unified stack, and finally wrap up with how to secure it all using AIP. Let's get right into it.
Section 1. The connectivity problem, specifically vertical versus horizontal integration. We're going to see exactly why the old way of writing custom glue code for everything is officially broken. When we break down the fundamental differences, things get incredibly clear. Think of MCP as your vertical integration. It's literally how an agent reaches down to interact with external tools and data sources. But then you look at A2A, and that's all about horizontal integration, how an agent interacts sideways with other agents. If you remember one golden rule today, make it this. MCP connects an AI to its tools, while A2A connects an AI to its team. Moving to Section 2, MCP, the tool layer. You can really just think of this as the hands of your AI.
You know the struggle with standard LLMs, right? They're stuck with stale knowledge and absolute no native access to your live enterprise data. Well, to fix that, Anthropic launched the Model Context Protocol back in November 2024. And just to give you an idea of how rapidly this thing is becoming the absolute industry standard, by February 2026, it had already crossed an absolutely massive 97 million monthly SDK downloads. That is huge.
Because before MCP, developers were constantly hitting a wall. We called it the dreaded M times N problem. M models times N tools basically equaled the total nightmare of custom one-off integrations. But now, MCP acts like a universal USB-C port for your AI. Under the hood, it uses a persistent client-server architecture over JSON RPC. Your AI acts as the client, and whatever you're connecting it to, your database, your Shopify store, whatever, acts as the server. The AI simply figures out what tools are available, uses this universal port, and boom, plugs right in.
All right, Section 3, A2A, the communication layer. If MCP is the hands, A2A is the AI's team.
So Google launched A2A to tackle a really specific headache. How do you get agents built by entirely different vendors to actually talk to each other? Well, it solves this using what they call agent cards. You can think of these as public resumes for AI agents. They list out an agent's capabilities and its API endpoints. Once an agent is discovered, A2A uses a stateless HTTP/JSON transport to delegate tasks securely. And it tracks those tasks through a very explicit lifecycle, from submitted to working, all the way to completed or failed. Plus, it even bakes in OAuth 2.0 for baseline security right out of the box.
Which brings us to Section 4, the unified stack and open infrastructure. Let's put the puzzle pieces together.
Both of these protocols actually sit under the Linux Foundation's governance. And when you look at their architectural differences side by side, it shows you exactly why they unify perfectly. See, MCP uses persistent, stateful sessions just to enhance a single agent's capabilities with tools. But A2A, it uses stateless HTTP remote requests to coordinate multiple agents. They literally do entirely different jobs. Making them compete is honestly like comparing a steering wheel to an engine. They aren't rivals, they're perfect complements.
Let's ground this with a real business example to see how it builds a complete workflow. Imagine you're processing an e-commerce return.
Step 1, your orchestrator agent receives the customer's request. Step 2, via A2A, it delegates that specific task to a dedicated return specialist agent. And then, Step 3, that return specialist uses MCP to connect straight into your inventory database to actually process the refund. You see? A2A governs the conversation between the agents, and MCP governs the agent's conversation with the data. Take either of those away, and the whole system just breaks.
Section 5. Securing with AIP. This is all about trust and identity, which is where things get really interesting.
Because look, even if you have MCP and A2A perfectly configured, you still have a massive missing link. Recent research cited a Gnostic security scan of roughly 2,000 MCP servers, and guess what? Every single one of them lacked authentication. Literally, the front door was left wide open across the entire multi-hop delegation chain. The problem is that while A2A and MCP tell agents how to talk to each other, neither of them natively verifies who the agent actually is. That is a terrifying security gap.
And that is exactly where AIP enters the chat, the Agent Identity Protocol. Instead of just passing along some basic, unverified request, AIP introduces these things called Invocation-Bound Capability Tokens, or IBCTs for short. Think of an IBCT like a super strict cryptographic allowance. It mathematically proves the agent's identity and strictly caps its computing budget. It completely unifies identity, authorization, and the history of the request into an append-only token chain.
So AIP becomes that absolutely critical security layer sitting across both your MCP and A2A transports. Using this changed token model, it gives you public key verification and something called holder-side scope attenuation. In plain English, that means when an orchestrator delegates a job to a subagent, it cryptographically narrows down the permissions for that specific job. The subagent literally cannot spend beyond its assigned budget, and it cannot widen its authority. Plus, the whole thing is tracked using provenance-aware completion records, which means you get full, crystal-clear enterprise auditability.
And man, the data backs this up flawlessly. In adversarial evaluations with over 600 attack attempts, we're talking scope widening, token forgery, depth violations, AIP achieved a literal 100% rejection rate. To put that in perspective, standard plain JWTs missed a full third of those attacks. They totally failed to catch things like depth violations and audit evasions. And the crazy part, AIP manages this with sub-millisecond latency. It takes up less than 0.1% of the total time in a standard multi-agent LLM inference cycle. It is insanely fast.
So, let's distill the whole shebang. The question out there was never really A2A versus MCP. It's about using A2A for your agent-to-agent communication right alongside MCP for your agent-to-tool connections. They work together. And above all, both of those protocols absolutely must be securely governed by AIP's cryptographic identity tokens. That is how you ensure safe, truly scalable enterprise deployments.
Now that you see the true cooperative nature of these protocols, I want you to ask yourself a question. Do you just have a bunch of isolated AI tools cobbled together, or do you have the complete, verified stack required to actually trust an autonomous, multi-agent enterprise? It's time we stop thinking in silos and start building the unified stack. Thanks so much for diving into this explainer with me today, and keep building smart.